What if you could turn a one-line idea into a detailed image or video prompt directly inside ComfyUI? And what if the same workflow could analyze images, break down videos, use MiniMax H3 prompt SKUs, and even run on a GPU with only 8 gigabytes of VRAM? That's exactly what I'm going to show you today. By the end of this video, you will have a complete local prompt assistant running inside ComfyUI. And I will also show you the settings that make larger GGUF models work on low-end hardware. Let's get started. Why run a prompt assistant locally, you might be wondering. If I can already refine prompts with ChatGPT, Claude, or Codex, why should I need a local model? For me, there are three main reasons. First, privacy. Your prompts, images, and videos stay on your own computer. The online platform may store your information or reject your request if they think your prompt is a violation of their policy. This happens a lot, I think.
Damn, I saw something bad, really bad.
Are you crazy? We were not supposed to see any user messages in our server.
Second, reliability. Once everything is installed, you are not dependent on an internet connection or a third-party service. And third, workflow. You can analyze an image, improve a prompt, and send the result into the next ComfyUI node without constantly switching between different apps. It gives the entire creative process in one place, the flow state. To run this latest Qwen3.8 model inside ComfyUI, we'll use the custom node linked in the description. This ComfyUI Llama TE node. I tested several similar options, and this was the easiest one to work with. It supports GGUF models, multimodal inputs, and partial GPU offloading, which is especially helpful if you have a limited VRAM. I have also prepared a workflow you can download. This one. If you're new to ComfyUI, don't worry. Install ComfyUI, start it. You could check my previous video on how to install ComfyUI, and then either open the workflow from the menu here, or just drag the workflow file directly onto these cameras. You should see 4 groups, each built for a different use case. And there's a button below the group, which you can use to enable or disable the group. Let's quickly test them before we get into the installation. The first group is for prompt expansion. Set the input mode here to text, and then enter a simple prompt like this. A girl walking in a dark forest. The system prompt below tells the model what role it should play and how the result should be formatted. As you can see, the model adds details about the environment, the lightning, atmosphere, etc. But the original idea stays the same. A young girl treks slowly through the dense, shadowy expanse of the ancient forest. This is useful when you have a basic concept, but don't yet know how to turn it into a complete generation prompt. You do have to use every details it gives you. Treat the result as a strong first draft, then keep the parts that actually fits your vision. The second one is image to prompt group. Let's disable this first and enable this one. Switch the input mode to image, load your reference image, and adjust the system and user prompt depending on what you want the model to analyze. You can ask the model to describe the subject, composition, lighting, materials, and textures. You can also load multiple images and ask the model to compare them. Like this. Here's the system prompt on AI Expert, and the user prompt is generate a detailed and a comprehensive English prompt based on the image. Let's click Run. Now you can see the detailed description of the reference image. If you want to compare images, just load another image and then change the user prompt to this one. Compare these two images and tell the difference. Link it to the user prompt view. Copy another show text note. Ctrl-Shift-V and right-click to only execute this note. And now here's the comparison result. Based on a detailed comparison of the two images, here are the key differences. State of the earbuds, presence of text, and the overall composition. The image prompt is a fast way to understand why a particular image works. For example, you can use this detailed description to develop a new prompt with similar visual characteristics while changing the subject composition and creative direction to make the result of your own to generate new images. The third group, analyze video. It works in a similar way, but instead of processing one image, the node samples frames from the video. Switch the input mode to video. Load your video clip and tell the model what you want it to focus on. For example, you can ask the model to identify the main action in the video, the camera movement, the character performance. One important settings here is max frames. This controls how many frames are sampled from the video and sent to the model. More frames can provide a more complete analysis, but they also require more VRAM and take longer to process. For a short 15-second video clip, 4 frames can be a good starting point. If the video contains fast actions or several scene changes, increase this number and test again. Here's prompt I used. This is the system prompt and this is the user prompt. Just change the image to video. Click run and here's the description with 4 sampled frames. Very detailed for a 15-second video clip. There's also a frame-by-frame mode. Instead of summarizing the whole clip, it describes every sampled frame separately, one by one. I won't spend too much time on this here, but it is useful when you need a more detailed shot breakdown. The final group is a local chat assistant. With the skill loader enabled, you can use the included MiniMax H3 prompt writing skills. All of them include other 8 specific style skills. If you disable the skill loader, the group works like a regular local chatbot. You can talk whatever you want with the model. You could right-click to bypass this node, and then right-click bypass again to enable it. One of the easiest way to learn a MiniMax H3 skill is simply to ask it. Select one skill like this 3D animation and tap something like this. What do you do and what information should I give you? And click send. And the model will explain the skill's purpose, what I do, what it needs, information you should give me, and how it structures the final prompt. And then you can provide a basic idea and let it guide you through the process. This is much easier than trying to memorize every parameter from the beginning of each skill. If you don't know how to use a skill, just ask it. Easy and simple. Now let's look at the model setup. Finally, you will normally need 2 files. The main model, Qwen3.8, 27B, GDUF. And the second one is this MMPROJ model. This gives the main model the ability to process visual inputs. If you only need text, the main GGF model may be enough. But if you want to analyze images or include images in the chat, you will need to load the matching project file as well. Make sure these 2 files are compatible. Better download them from the same model release you can see here. This is Onslaught, and this is the Q4 model, the GGF main model, and this is the project model. Either one is okay. If you have a 20 series GPU, you could use this F16 version. Others use this BF16 version. And this one, uncensored one, it also provides a uncensored vision. But if you want to use this vision model in this node, you need to change the vision to this one, MMPROJ, or else it will not recognize this model. This is a small bug of this node. And as you can see here, they also have different quantization options, such as Q2, Q4, and Q6. In general, larger quantizations can preserve more model quality, but they also need more RAM and VRAM. For most of the people, Q4 is a practical place to start. If you want the entire model to run on your GPU, the model plus runtime overhead needs to fit inside your available VRAM. For example, if you have a 16 GB of VRAM, you can choose this version or this version. If you want to choose this version, which is 19 GB, bigger than the size of your RAM, we can offload some of the models to the system RAM. The key setting is these GPU layers. Our DUF model is divided into layers. As you can see here, 64 layers. And this setting controls how many of those layers run on the GPU. A higher number usually gives you a faster generation, but it uses more VRAM. A lower number moves more work to the CPU and the system RAM. That reduces VRAM usage, although generation becomes slower. In this node, -1 attempts to place all supported layers on the GPU. 0 means run the model through the CPU. Yes, you can run a GGF model totally on your CPU and RAM. And the numbers such as 10 offloads only that many layers to the GPU. Let me show you a real example. I'm using this Q4 model with a simple MiniMax H3 video prompt. Like this text to video, realistic style, a girl walking through a dark forest, 5-second, 16:9 ratio. Using this standard H3 prompt writing skill to refine this prompt. First, I'll set GPU layers to -1 to run all the models on GPU and see how much VRAM it takes to run this Q4 model. Open Task Manager to monitor the VRAM usage during the generation. Clear the VRAM first, and then click Send to execute the prompt. You can see in Task Manager, the VRAM usage reaches almost 20 GB on my local system. Now I'll change the GPU layers to 10 to run only 10 layers on GPU. Clear the history first and use the same prompt and the same seed and clear the models. Click Send to execute this prompt with GPU layers 10. At this time, the VRAM usage stays below 8 GB, but the trade-off is speed. Moving more layers to the CPU makes the model noticeably slower, from 30 seconds to 200 seconds. So the goal is not just simply to use the largest model possible. You need to find the best balance between quality, speed, VRAM, and the system RAM for your own computer. Your result will vary depending on the model conversation and the node version. Downloading the model files is quite straightforward. As shown in this node, just place the main model and vision model under this ComfyUI models LRM directory, like this. Lastly, let's talk about the installation of this node. Use git clone to install this node. Go to your custom nodes folder. This one, type in cmd, enter. Run this command, git clone, and then paste the link you just copied, the node GitHub address. Press enter. Since I have already installed this node, so it shows fatal. It's not an empty directory. But if you haven't installed this node yet, it will install this node for you. But as you can see, this custom node is based on Llama CCP, so you may also need to install a compatible dependency wheel. This wheel must match your operating system like Windows, Linux, or Mac OS, and Python version, and the PyTorch or CUDA environment. Here's how you can check all these informations. If you are using the ComfyUI portable version, open the embedded Python directory. This one, Python embedded directory. Click the address field, type cmd, press enter. To check the Python version, run this. Remember the V is a uppercase V, and then press enter. You will see the Python version. Next, check PyTorch and CUDA package. Python-m pipe list. First enter. Here, under this torch, you can see your torch version is 2.13 and the CUDA version is 1.30. Just remember this too. Now open the will download page linked in the description. This one, GitHub, Jame, Pen, Llama CCV, Python releases, and find the files that matches your environment. For example, my setup uses Python 3.13 and CUDA, so I need the Windows will build for those versions. Windows and Python 3.13 and CU130. This one. Right click and then copy the address link. Go back to the window. Type in python-m pip install and then paste the link you just copied. The will link. Press enter. Wait for the installation to finish and then restart your ComfyUI. If the node loads without any errors, you are ready to go. And this is how you can build a local prompt assistant inside ComfyUI. Even if your GPU doesn't have enough VRAM to run the entire model, the workflow can expand rough ideas, analyze images, break down videos, and help you write structured MiniMax H3 prompts without leaving ComfyUI. You will find the workflow, custom node, model links, and dependency page in the description. If this tutorial helped, please give it a like and subscribe for more practical ComfyUI workflows. Thanks for watching, and I'll see you in the next one.